Okay, so today we will be talking about simplifying an algebraic expression over here. And today we will be trying to work out some of the examples over here. Alright, so let's start with the first one over here. Now again, we already know how to deal with fractions, but the problem is right now we have some unknowns over here. So again, we can't use calculator to show you what's the answer for this right now, right? But regardless how the fraction look like, the operation of fraction, either you are adding it, subtracting it, multiplying it, or dividing it, it's still the same, all right? If you are dealing with numbers or unknown, it's still the same. So let's take a look at this example over here. Right now, my denominator is the same, so based on the fraction rule, I can add the numerator, right? So when I add them, x plus x, that will give me 2x, and over the denominator, 6. That's all right? But over here, if you notice over here, this 2 and this 3, I can still further simplify because there are some common factors over here. So this will give me 1 and that will give me 3. So my final answer will be x over 3. I'm done. Okay? Look at the second example. There's a subtraction involved over here, but this time my denominator is not the same. So before we can subtract, what can we do first? We can make the denominator the same. But in this case, what should I multiply? So if you notice for this fraction, I should multiply 2 over here for this fraction. Alright? So what do I get now? So what I will get now will be, let's see, 8 minus 5, and everything over here, that's going to be over 2y. So 8 minus 5, that will give me 3 over 2y. Okay? I have done simplified the algebraic fraction over there. So let's continue with this again. Okay? So again, if you notice over here is an addition, but my denominator is different. So what can I do over here? I can make the denominator the same first. So what I'm going to do over here is for this fraction, I'm going to multiply it with 3p, and I should do the same for my denominator. And whereas for this side of the fraction, I will multiply this with 5 and 5 as well. Okay? And then I'm going to multiply now. So 3p multiplied by n, that's going to give me 3pn plus 2 times 5, that will give me 10. And everything over here, it's going to over 15p. Okay? Now, if we look at the fraction now, is there anything else I can simplify? There's none already. Okay? If there's none, that's my answer. Okay? That's my answer. Alright? There's nothing else I can do over here already. So that is my answer already. Okay? Now let's go on to the second example over here. This question over here. Now, how do we simplify this? Okay? Now, again, this is again a fraction. So if you can't see what is going on over here, my suggestion is to take a step back. Take a step back so you understand what's going on. So if you notice this, it's very similar to this, correct? But where does this come from? It comes from this one, correct or not? So actually, I can rewrite this as this. I can rewrite this as 6x over 3 plus 3 over 3. Right? That is basically what this long line means. So over here, I can simplify this side, which is going to be 1 and 2, and this is going to be 1 and 1. Right? So my final answer here, that's going to give me 2x plus 1. That's my final answer. Now, a common mistake that students will always do for this type of question is this. They will always forget this is actually looks like this. Okay? So a lot of students will just like cancel this 3 and 3, and then this 1 and 1, and then they say their final answer is 6x plus 1. This is a very common mistake that students will make. So please be careful with that. Alright? So it's always good if you do not understand what does a fraction mean, take a step back and write it like this so you understand what's going on. Okay? So let me erase this. Alright, so for all these questions, I can also use the same way to do, but I'm going to show you a different way to solve this as well. Because since we have already learned about factorization, so I'm going to utilize that technique to help me simplify this easier, okay? So let's take a look over here. Now, if you take a look at the numerator, is there any common number that I can extract out? So if you think that it's 4, you're right, okay? So if I were to take out 4, all right? If I were to take out 4, what's gonna be left inside the bracket for the numerator? That's gonna be 2x plus 5, right? Okay? Over 4 over here, right? Over 4 over here. Now what can I do over here right now? Now for those of you, if this is something new for you and you are not sure what to do with it, this is what I'm going to suggest, okay? This is what I'm going to suggest. I'm going to use the let again, alright? Okay? So I'm going to say, let's ignore this question for a while first, huh? I'm going to say, let 2x plus 5 become, let's just say, a, okay? Alright, so I can rewrite this equation as 4a over 4, right? Now, if you take a look at this, is this similar with this over here? So what did we do over here? We can just simplify the numbers, correct or not? So this one is the same thing. I can just simplify the number and my final answer is only a, which is 2x plus 5. Can you see that? Okay? So basically, in another word, if you have trained your eyes to look at this like how I see over here, when we look at this, what we can do directly is just cancel out these two numbers. Alright, that will give me 1 and 1, and what is left is just 2x plus 5. That's all. Okay? Why is this possible? Because of this. Okay? Oops. Now I'm going to write this question lower so you can see. Okay? So it's the same thing over here. Huh? So again, this question, right? Let's take a look at this question again. So same thing, all right, rather than doing this way, I can utilize my factorization method and factorize this. Okay, so let's see what do we get over here. 10 and 30, what are the common factors that I can extract out? So actually there are few options, correct or not? So if you take the biggest one, okay, which if you say it's 10, all right, let's see what's gonna happen first. So let's just say if I take 10, what's going to be left inside the bracket? That's going to be x plus 3, correct? And everything here is going to over 5, okay? And then again, we can do something similar over here, which we can cancel here. That's going to give me 1, and that's going to give me 2, all right? So right now, how does my equation look like right now? So this guy is going to look like this right now, 2x plus 3, right? And finally, we want to simplify this so we can expand this, so that's I will get 2x plus 6. Okay, done. But over here, some of you might notice, instead of bringing out 10, can I bring out 5 instead? Okay, can I bring out 5 instead? Okay, so let me just do another one over here. Now I will show you why bring out 5 is actually a better option rather than 10. Although in the end of the day, you will still get the same answer, but sometimes we want to try to learn to do our work more effectively, right? More efficiently. So let's see over here. So I have 10x plus 30 over 5. So instead of taking out 10 like I do here, I take out 5. Now why do I do that? Now if I take out 5, I should have 2x plus 6 in the bracket, and I will have 5 over here. Now why is taking out 5 a better option? Because my denominator is a 5. Okay, so I know that I can cancel them directly, and there's nothing else I can do with this bracket. Okay, so that's my final answer already. Okay, is this basically compared to this, is this one step faster, right? So sometimes when you want to simplify a fraction, algebraic fraction, it is much more better to to extract out a common term that you can cancel out with the denominator. So that might help you to simplify much more faster and easily. But if not, you will still get the same you will still get the same answer, but that might take you one more additional steps. Okay. Now let's try this final example. So my question over here is to simplify this. Now this might look complicated, all right? Okay, but it's the same thing. We're going to apply what we understand from here and apply over here. Now, some of you might think when you look at this question, it's an addition operation, right? So there's 2 and 5, my denominators are different, correct or not? So I can actually make the denominator the same, correct or not? Now you can do that, but that will be a longer way to solve this. You will still get the correct answer, but you will just take a longer way lah. So instead, why not take a look at this algebraic fraction and think of if you can factorize something first from their individual fraction. Okay, now let's take a look at this one. The numerator, there's something I can take out, right? I can take out 2, right? So if I take out 2, what's going to left in the bracket? That's going to be 3x minus 2. Everything here is going to over 2. Let's write that down first. Plus, my denominator is 5, so can I take out 5? Seems I can. So if I take out 5, what's going to left? 4x plus 5, everything is going to over 5. And just nice, we can cancel this out. And what's left? So what's left in my expression over here, that's going to be 3x minus 2 plus 4x plus 5. Okay? So again, what can we see? We see like terms. So we can add them together. So 4x plus 3, that will give me 7x. 2 plus negative 2 plus 5, that will give me positive 3. Okay? Done. So that's my answer after I simplify this. Yeah, okay? So for those of you, if you want to try making the denominator the same, eventually you will still get the same answer, but that might take you slightly longer. Okay? But regardless, choose the way which you feel most comfortable. Right? Last question. Same thing over here. I noticed that there's something I can factorize out for the numerator, which I can cancel out with the denominator. That's going to be 7. Let's take that out. So what's going to left is going to be x minus 2, right? So over 7 plus, for this side, it seems I can take out 2, and I can take that and cancel with this. So if I take out 2, what's going to left is going to be 4x plus 3. Everything is going to over 2. And just nice, I can divide all this, okay? So what's going to left over here, that's going to be x minus 2 plus 4x plus 3. So same thing like above, there are like terms that I can add up. So what do I get over here? X plus 4x, that will give me 5x. Negative 2 plus 3, that will give me plus 1. Okay, I'm done. Okay, so over here, this is how we simplify algebraic fraction.